go. Okay. Well, thank you very much, Mike. And it's a pleasure to be at UC Santa Cruz. I have heard a lot about the campus from the former dean, Steve Kang, who I knew very well. He was a colleague at the University of Illinois at Urbana-Champaign. So what I'm going to talk about today is a modern research lab, and specifically a case study of HP Labs. And the reason I decided to choose this topic is across the world, corporate research labs today are facing a challenge. And the challenge is, how much alignment do you have with your research with the various business units in terms of, do you directly transfer the research to products and services that are relevant to the company today, versus trying to do a lot of basic research, fundamental research. And times have changed. When sort of the Bell Labs, the famous Bell Labs of the illustrious past were created, essentially they were leveraging off a monopoly, right, where revenue was not an issue. And so you could essentially do whatever you wanted to do, and including sort of Nobel Prize winning work in various fundamental areas in science and engineering. Not true today, right? So many companies are struggling with what is exactly the role of a corporate research lab. HP Labs started about 42 years ago. It was a vision of the founders, Hewlett and Packard, that you definitely needed to have a central research lab that will provide opportunities, technology opportunities, beyond the roadmap for HP, the mothership, right? And many corporate research labs, they say, well, we need to be more relevant to the company in today's economy. And so they swing the pendulum to very much product-focused research. And sometimes you swing the pendulum back and say, oh no, this is way too focused. Let's do basic research. And it becomes 100% academic. And then you risk losing the support of the mothership. So what we went through last year is a really deep thought experiment. What is the right trade-off for a corporate research lab in today's environment? So I'm going to talk briefly about our findings. So I'll talk briefly about the organizational overview. And then most of my talk, I'll talk about the research themes that we have decided to pick, the exciting research projects that we are launching at HP Labs, and our plans for transferring those research ideas to various business units. And finally, I'll end with some thoughts about open innovation, how labs such as HP Labs can partner with universities and other companies and leverage these relationships to amplify what we do. Because after all, the problems that we are trying to address are so complex, you cannot do it within the 500 or 600 people that you have in a particular research organization. So that is the context. But let me start with a conversation around HP, the company, and its R&D enterprise. HP today is a $130 billion company with its recent acquisition of EDS. And it has 4 large organizations. The IPG, Imaging and Printing Group, it creates, sells the printers, copiers, all the wonderful, the inkjet printers and deskjet printers that I hope you have in your offices. That is a nearly $30 billion business, led by Vomesh Joshi. Then the Personal Systems Group, led by Todd Bradley, develops, manufactures, sells the laptops, notebooks, workstations, and all those wonderful things. And that's a $40 billion business. TSG, run by Ann Livermore, produces the servers and storage and software. And that's another $40 billion business. And then EDS is our latest acquisition. It runs the services arm for HP. Together, these divisions bring in $130 billion. Of that, $3.6 billion is invested by HP into R&D. Now, that's a lot of money. That is a lot of money, right? And there are collectively 30,000 technical contributors at HP working on the next generation printer, the next generation laptop, the next generation server, storage, software, etc. They are the real engineers creating innovations for you, the customers. But in addition, HP Labs is the central research arm for HP. We are small. We are 5% of the budget, about 5% of the people, very small compared to the large enterprise. 600 researchers, about $150 million budget. But that's what we do directly, and our role is to work on topics that are beyond the roadmap. But indirectly, we influence the 3.6 billion. So directly, we are working on 600 researchers and so on establishing the future roadmaps, but we also form ties to these 30,000 technical developers. So that's our role. HP Labs has 7 locations around the world. When it got started about 42 years ago, it was located basically in Palo Alto. And today, even today, a majority of the researchers are in Palo Alto. So of these 600 researchers, mostly PhD, about 350 are in Palo Alto, about 150 are in Bristol, and then we have about 30-ish researchers in Haifa, Israel, Bangalore, Beijing, Tokyo, and we just started a lab in St. Petersburg, Russia. These 600 researchers are one of the most brilliant minds that I have seen in my career. Fantastic technologists, fantastic scientists. Many of them are fellows of IEEE. There's, I think, about 11 fellows of IEEE, about 10 fellows of ACM. 7 are HP fellows, 4 are HP senior fellows, 2 of them are members of the National Academy of Engineering. We have Turing Award winners. We have the whole slew, some really fantastic talent at HP Labs. But as part of the reorganization that we did, and I will spend a little bit of time on this, the vision was, how can we harness the creative energies of these 600 brilliant minds and reorganize them into between 20 to 30 labs of 20 to 30 people? And then what should these areas of the labs be focused on? So looking into the future, right, the 21st century, what are the research problems that are the most exciting, challenging problems facing customers in the next decade? So as part of a huge strategic planning exercise that was actually led by one of my colleagues here, George Dees, if you can, so he is here checking that I don't bend the truth. So it was a tremendous experience that we went through at HP Labs. And the result is we have identified 5 broad themes for research in these 23 labs. And then we have moved people in a direction that is away from doing a large number of smaller projects. We had about 150 plus smaller projects going on with a couple of people working on those projects, which was very difficult to have impact to the company, into a direction that will identify between 20 to 30 large projects, big bets, involving about 12 to 20 researchers per project and having some really massive impact in those projects. The other thing that we decided to do was to make sure that we do a balance of how much research we do in fundamental research and how much we do in product-related research. And our objective was to do 1/3 of our work in basic research, 1/3 of our work in applied research, and 1/3 of our work in product development kinds of research. The product development research would have timelines of between sort of 6 months to 18 months, applied research 2 to 4 years, basic fundamental research 5 to 10 years and beyond. So we will do those research, but in these 5 broad themes. The 5 themes are information explosion, content transformation, cloud services, intelligent infrastructure, and sustainability. And I think many of you in the Baskin School of Engineering and the faculty and the students will see that these are very relevant topics for many of you to work on moving forward. But before I go, so I'm going to go deep into each of these areas, but I thought I would share with you that we reorganized the labs into 23 separate labs. I'll not show you all the lists, but to just show you some examples. So you have the Information Quantum Systems Lab led by Stan Williams, an HP Senior Fellow in Palo Alto, contributing to a couple of themes, the information explosion theme and the intelligent infrastructure theme. We have the System Security Lab in Bristol led by Martin Sadler, contributing to dynamic cloud services, intelligent infrastructure. The Innovations for the Next Billion Customers Lab in India led by Ajay Gupta, contributing to cloud services and content transformation. So essentially we are trying to create a matrix. You have the 5 broad themes, 23 labs, and they're contributing to those areas. The last part of the puzzle is how you actually identify research projects to work on in labs. And this is something that I drew upon from my experience in academia, that you give the researchers the freedom to propose really wild, big bets projects. And these projects proposals look like a combination of an NSF proposal that academics put forth, that is it's just saying how you're advancing the state of the art in the field, and it is also like a business plan for a startup which is saying how you're going to make money on this. So essentially what HP Labs projects are trying to do is to identify how you're going to move the needle in the technology, as well as if you are 100% successful with your research, let's figure out what are the possible business opportunities for those technologies. Now to assist labs in making sure we make the right bets, we have organized a research advisory board which consists of 1/3 representatives from business units, 1/3 technologists all across HP, and 1/3 lab directors. And this group of individuals, they're almost like managing partners in a VC firm. They're looking at these proposals and they need to collectively make sure they hit 1/3 basic research, 1/3 applied research, and 1/3 product development. So this is, I started the talk saying corporate research labs have this challenge, right? How much alignment do you have with businesses? How much non-aligned do you want to be? And if you do 100% non-aligned, then the CEO of the company asks you, are you working with business units? And if you become 100% aligned with business units, then the question is, if you are doing that way, then why are you a corporate research lab? So by having this sort of 1/3, 1/3 ratio, we think we have tried to solve the problem. Simultaneously, we are trying to identify these big bet research ideas. And so that's the structure. So those rectangular boxes are the labs, and those ellipses are the large research projects within the labs. And they're all trying to contribute to those 5 broad themes. So that's the organizational background that I wanted to talk about. Now what I'm going to do is, in the next half an hour, I will actually talk about the research themes and a sampling of research projects that our researchers are working on. So the first theme is that of the problem is that of information explosion. In a small way, each of us are contributing to this massive information explosion problem. The amount of digital information that is being created in the world is doubling every 18 months. look at it another way. The amount of information that the world will create in the next 5 years, from 2008 to 2013, will be more than the information that the world has created in the history of the world. So look at all the information that we have created thus far, till 2008. In the next 5 years, we'll create more information than has been there from the last 10 billion years to 2008. And that is a massive problem. And why? Because we are each contributing to this mess. We are taking pictures on digital cameras, uploading them to Snapfish, sharing them on Facebooks and other social networking sites, taking videos, uploading it to YouTube, sharing it, attaching videos in emails, blogs, and the whole thing. Companies are storing all kinds of information about its customers, about its operations in Oracle databases, SQL databases, ERP systems, SAP systems. So there's a massive amount of data being stored in structured data and unstructured in emails and blogs and so on. And how do you make the problem of this, really solve this information explosion problem? So how do you reduce the complexity of analyzing that information while ensuring security, do it at massive scale to deal with these hundreds of petabytes of data, and do it in real time? So that is the grand challenge. So we have a couple of research projects in labs that I will talk about. The first one is this model-based information management system. We call it MIMSI. This is a project going on in our enterprise informatics lab in Bristol. So they are building up on a lot of very fundamental work they have done on the semantic web, trying to leverage off structured data and unstructured data, and automatically for a machine to build an information model, an information map of the information that exists in an enterprise, in a consumer, or an SMB, and produce that information very rapidly so that end customers can use it for its own business intelligence and business insights. So there's a lot of fundamental work that is needed, and we are using a demonstrator. The demonstrator is the world of e-discovery. So as we create the fundamental technologies for information explosion, information management, the application area is the area of e-discovery, where imagine a company being asked by a judge to produce all information relevant to this company's dealings with these 5 partners in Nigeria between the years of 1992 and 1997. It will be very hard to gather all this information from printed documents and so on. But if you could do it from partly structured, unstructured data in real time, and this could be tremendous savings in that work. So e-discovery is a demonstrator trying to motivate the problem and solving fundamental problems in this area. A second cluster within this is operational business intelligence. We all know that companies such as Walmart do a great job in data warehousing. They have all this data on all the locations around the world, around the US, and they use it to great insight. They do data mining, they do all kinds of information extraction from that data. The trouble is today it is an offline operation, right? So you do whatever stuff, you move things from a data from a shelf in Walmart store in Santa Cruz, and then at the end of the day they will do this massive data mining, and they will try to project what happened and do things reactively for the next day. Imagine if you could do all this thing in real time. As soon as a particular thing is happening, you could really derive in real time business intelligence on data on massive scale. That is the vision of this particular project, led by Umesh Dayal in our lab in Palo Alto. Moving to the next theme, that of cloud, in the general area of cloud computing. So cloud computing has now got a lot of hype in the press. Very simply put, what cloud computing does is allow people to move to access computing and storage resources from the internet. instead of owning your own IT infrastructure, you let some provider own and manage your infrastructure, and you just go and access it, right? So one simple reason for doing this is just to reduce the cost, right? I mean, and sharing the infrastructure. When an organization, you acquire the infrastructure, you are over provisioning. You think you may need 10,000 CPUs at the end of the month on a particular day, and for that you are acquiring 10,000 processors, and through the rest of the month you don't need it, but you have it, and so you are essentially wasting resources. Whereas if you could get the resources on demand from the web, that could potentially save you some money. So that was the initial motivation for cloud computing. And Google and Amazon have provided that service, right? You can rent CPU at 10 cents an hour from, for example, Amazon's EC2 service, and you can rent storage at whatever, a couple of cents a gigabyte from the S3 service. But it's beyond that, it's beyond cost. It's about providing more value. So there are these very interesting services that you can compose on the cloud that will deliver much better experiences to the user, to the consumer, and much better experiences to the businesses, much better business-to-business interactions, business-to-consumer interactions, and so on. So we are working on technologies that will allow people to dynamically provide services based on their location, where they are, their preferences, who they know, within a personal setting as well as in a business setting. So that's kind of the grand challenge. Specifically, I'm going to talk about a couple of projects at HP Labs. So to solve this problem, we are taking an approach that we need to solve first problems at the infrastructure level, and I will talk about the infrastructure for the cloud in a future slide. But then essentially, in order to create this environment where you as a consumer or an SMB or an enterprise, if you want to access a processing resource or a storage resource, instead of accessing real physical resources, you will actually access virtual resources. So essentially, using the concept of virtualization, this cells as a service project is creating an environment that you could create virtual processing cells and storage cells in a truly scalable manner. We are talking about not tens of processors, hundreds of processors. We are talking of hundreds of thousands of millions of processing cells. So to do it at massive scale on physical processors and storage that may be physically distributed across the globe, and while doing this in a completely secure manner. There are tremendous challenges to doing this kind of stuff, and that's what the Cells as a Service project is doing in Bristol. Sitting on top of Cells as a Service is a project called Mercado, where the concept is, suppose you are a small business and you're trying to create a new web service. You are interested in business outcomes. You're not interested in I need 4 processors and 9 gigabytes of storage. You don't care about those things. You care about services that you want to dynamically compose based on your business needs. So imagine that you are trying to create a business for creating magazines. I know there is a couple of people from the communications world here, right? So what is needed in a magazine? You need the content. So there's a bunch of people that in the traditional IT world, they would be in the content creation world, the writers and editors and those kind of people, right? And then you need a way to actually print that content. So you need a whole bunch of printers, the print service providers and all those kind of stuff that will take your content and produce glossy magazines on those things. Then you need to be able to sell that content. You need to be able to produce ads. So you need to bring in subscribers and users, right? You need to pull ads from that. And then ultimately you need to have a way for people to buy the magazines and so on. So there are different sets of services that you need from a business perspective. And imagine if each of these services were available on the web, on the cloud, how can you compose these services automatically? And that is the vision of Mercado. The magazine example that I just talked about is actually another project called MagCloud that is sitting at, and HP Labs has just created this very interesting web service so that the whole concept of creating magazines can be democratized. You and I and everybody could create a magazine that will have only maybe a 300 subscribers, but it still makes sense to produce a really high quality magazine because anybody can do it, including putting in ads and printing and delivery and using how to charge your credit card and how it gets delivered to the right person. In fact, MagCloud has a very interesting statistic that I want to share with you. There are 3.2 billion magazines that are printed every year. 3.2 billion. Of that, 62% of the magazines are never read. They just return. So 2.4 billion magazines are just trashed without even looking at it. That's a bad thing for the environment, right? Imagine if you could print on demand that when George Dees in HP Labs wants to have his custom version of Newsweek magazine with the custom content, he could do it and be printed for him. That's an amazing thing. And those are the kinds of things, the value that you could do through cloud services. The next theme is that of content transformation. And what this is trying to do is to essentially say, you have a lot of content, digital content, and how do you create tools to digitize the content? So from the sort of physical world to the digital world. And then once you have it in the digital world, you need to transform the content from one place to another. And then ultimately you need to transform that content from the digital world back to the physical world. And so this digital to the physical world is this area of printing, and this area of digital commercial printing is an area that HP Labs has really decided to focus on. So what's the problem here? There is, on the web, there is about 50 trillion pages that are printed every year. Only 8% of these pages are printed on what we call today digital printers. 90% plus of the pages are printed on what are called analog printers. These are printers with plates, printing plates and so on, the large Heidelberg presses and so on. And those prints are happening in things like the Wall Street Journal, USA Today, New York Times, San Francisco Chronicle, right? So, but those newspapers, they're not customized. You cannot have print on demand, custom things for you as an individual. Now, my sports interest is more in, say, cricket, because I'm originally from India, right? And in, say, soccer. But the real estate space on the New York Times gives it soccer only just a few inches because it's talking about all kinds of other sports. But imagine that New York Times knew about my personal preferences. I could talk about soccer and cricket and those regions of the world that I care about, and be printed in New York Times, customized for me. That is the world of digital commercial print. Now you cannot do it today because the cost is very high, and the throughput that you require to do a 10 million newspapers is so much that you would not be able to do in today's commercial printers. But the digital commercial print engine project at HP Labs is addressing those precise problems. So trying to see how you can take these large indigo presses from HP and trying to develop fundamental technology in the chemistry of inks and iron heads and how you actually take content and put it onto paper and do it such that the cost per page is 1/10 the cost today and the throughput is 100 times what you have today. Only then will you be able to displace the analog printers, the Heidelberg presses and so on. And this is a multi-billion dollar opportunity. That's a big challenge. In the area of content transformation, there's another technology, a project called Connect Us, which is making the observation that individuals come and meet in physical locations because the interaction is the key. Right? I drove over from Palo Alto to Santa Cruz to give this talk because I need to look at your eyes and emotions and so on. This interaction, the physical interaction is fantastic. But imagine a world that I did not have to come here. So that's the world of 30 years ago, we did phone calls. Now you do video conferencing. But video conferencing today does not give you that really personal touch. There are technologies developed at HP, actually it came out of HP Labs, called Halo, that if you sit in a Halo room, in a conference room, you appear as if you're almost there. And there are competitor technologies from Cisco, telepresence that do those kinds of things. The trouble is, to enable you to provide those really high quality video conferencing capabilities, you need to invest in $100,000 conferencing rooms with dedicated lines and all kinds of stuff, which does not democratize this whole area of collaboration. And Joe the plumbers in the streets, what do? We use Skype. Right? So if you ask Joe the plumber, he'll say, I use Skype. Skype is cheap, but Skype is not high quality. So can we create a technology, the quality better than Hello at the price of Skype? That is the vision. So you need to do fundamental things in research in areas such as visual experiences, video background replacement, video coding, and all kinds of cool stuff to enable this vision of Connect Us. It's a very, very large bet that HP Labs is making. The third theme is that of intelligent infrastructure. This HP is basically the largest IT infrastructure company in the world. So we design devices such as PDAs and laptops and so on. We design the network, we design the infrastructure, design the server, storage, and software. And so how can we move towards a much more powerful infrastructure, much more intelligent infrastructure in the future? That's the vision of this particular theme. So I'm going to talk about two large projects in this area. The first one, which I'm very excited about, is this Exascale data center. So we all know that there are data centers in various companies having 1,000 processors and so on, and HP has very large data centers located in Atlanta, Houston, etc. Right? But those data centers are designed for today's workloads, the large transaction-based workloads and so on. But imagine the need for the future, say in the world of cloud computing, where you will require not 10,000 processors, 100,000 processors, millions of processors, where people are doing not a million transactions, a billion transactions, hundreds of billions of transactions of different types of capabilities of the workloads of the future. What would that architecture look like? So what is Exascale? I mean, you all know about mega. Mega is a million. 1,000 mega is a giga. 1,000 giga is a peta. 1,000 peta is exa. So this is massive, massive, massive scale. So we are working, our researchers are working on how do you do the memory blade technology for such a data center, the processing blade, the storage blade, and the virtualization software that goes together. Very exciting project, led by Partha Ranganathan in the Exascale Computing Lab in Palo Alto. The OpenNet Project between the ECL lab and MCNL lab has this vision that we have gotten to the internet, the networking today, through a set of incremental evolutions from where the internet started 30 years ago. When the internet was created, it was created for the world of email and file transfers, FTPs, large data transfers between people that really did not need any real-time interaction. What do you do with the internet today? Not just email and FTP. You do real-time video, you do transactions, you do e-commerce and so on. So people are trying to do these various protocols for networking by solving this problem and that problem, and essentially it's a real mess out there. So if you could, the vision is, if you could start from scratch with a completely clean slate, this is what you need to do today, right? How would you design your network? In a completely open programming, with a completely open programming platform, depending on the kinds of needs that you have as end users. You have quality of service needs, fine, we'll address that need. You are willing to pay more, pay less, you have different market-based payment mechanisms or whatever. How can you design an open programming platform for networking switches of the future, working with our industry partners, our partner called ProCurve, and coming up with this kind of vision. If this works, this would be a huge, huge, significant change in the needle in the networking space. The fifth theme is that of sustainability. And what this is, it is about the recognition, realization that we are collectively consuming a lot of energy, which is bad for the environment, right? And so as you consume more energy through electricity or whatever, then you are creating greenhouse gases as bad for the environment, creating global warming, all that kind of stuff. So, and HP is a major IT company, and we have a responsibility. So what is HP's role to sustainability? How do we create an ecosystem that lowers the carbon footprint? Now the challenge is, you can come up with very creative solutions to lowering the carbon footprint, but it costs so much that customers will not make that choice. So you have to do it while reducing the cost. There has to be a solution that has business value as well as environmental value, right? And so the concepts that we are working on here, and this is a very broad topic, is to look at not just a particular system by itself, but to look at the demand side of the network and the supply side of the network, right? So on a data center, think of it, to power the data center requires 100 megawatts of power, right? And you can do various things to reduce the power consumption. And we have done some phenomenal work at HP Labs on things called dynamic smart cooling that says, you know what, you don't have to cool this entire data center room to run it at 30 degrees Fahrenheit, and so when you walk in you are freezing. Instead, you be smart about how you cool specific regions of your data center by having a bunch of smart centers throughout the data center and sending the right air conditioning to the right places so that the overall cooling costs go down. So your total cost of energy ownership goes down by about 40–50%. We have done that kind of work, but that's the demand side changes. You could do things at the supply side. Do I have to completely depend on electricity from the grid? Can I depend on photovoltaic? Can I depend on wind? Can I depend on this? And can I adjust things? So there is some really interesting stuff that is going on in a project called the Sustainable Data Center Project. In the future, we'll come up with a solution to a data center from an end-to-end perspective, not just looking at within the data center will consume less energy, but looking at the workloads that are there, looking at the service level agreements that are there for the workloads that are running on my data center, and coming up with a solution where we do certain things at the supply side in terms of energy sources. We are building a demonstrator having fuel cells and photovoltaics and grid and so on, and adjusting the supply side as well as the demand side, and shutting down servers, shutting down stuff, and coming up with a truly sustainable solution within the world of data centers. There's another project that is going on, which is a project on tools and methodologies for designing a sustainable ecosystem, which is saying as you build products like laptops and servers and so on, you use different materials. And depending on the kinds of materials you use, if you could look at the fundamentals of how much energy, available energy are you using, consuming to create this product. So the currency is not just dollars. The currency is, as Chandrakant Patel says, from the second law of thermodynamics, exergy or available energy, it's a currency in joules. Joules, not jewels. And so the vision is, if you could create an environment that if I use this bauxite material to create the aluminum for this cover for the laptop, and if I use this other thing from iron oxide, what is the energy that you need to actually dematerialize it and deconstruct and construct this material? End customers could make a choice. This product was using this much exergy, this many joules, this used this much, and environmentally friendly customers can make those choices. So it's a very broad vision, and we are trying to work on that. The last project I want to talk about is kind of spans across content transformation and sustainability. It's a very interesting project called Nebula, which is an interactive information surface. So we all interact through information that we have on printed pages. Each of you have a printed copy of today's program, right? And this is very environmentally, it is good in a way that you are not using a light emitting diode to display it, right? You are relying on the ambient light to reflect off that paper, and you can see it. The display that is going on here on my laptop is a light emitting diode, LCD or LEDs or whatever, which is fundamentally sending sort of, you're taking electrical energy, converting into something so that you can see it. So it's an emissive form. But imagine a display that will be reflective, which will rely on ambient light. I have a laptop, I walk into here, there's no light that is coming in from that back. You will leverage off the reflection. You take a laptop today, you go to this beautiful side outside, you cannot even read what is in the laptop because the illumination from the laptop cannot compete with the sun. But if it is a reflective, you go outside and look fantastic. So the vision is to create flexible plastic kind of displays that are reflective, and the quality is as good as paper, better than paper, but you could also change it because in paper you cannot refresh it. So, I mean, it's very interesting technologies that are being developed in the Information Services Lab in Palo Alto. Having talked about the main thing that I want to talk about, the 5 broad themes: information explosion, content transformation, cloud services, intelligent infrastructure, and sustainability. Collectively, these 23 labs are working on these 5 broad themes. In those projects, this big bet project that I talked about only 10. There's 10 other very interesting projects going on, large projects. Now the issue is, in about 3, 4, 5 years, when these research results are successful, how do we transfer them to businesses so that it shows up as real products and services in the hands of customers? If you think in academia, I mean, we are all in, I mean, I used to be in academia, I used to be in engineering and so on, right? And so I had struggled, right? When I was a professor at University of Illinois or at Northwestern, we were creating all these cool things in the world of electronic design automation or compilers. I used to give the tool to Intel, give it to HP, give it to IBM. Oh, fantastic, fantastic, good. And then it went nowhere. So the key thing in technology transfer is when the technology transfers along with the people. The people who initially create the technology, unless those people, the passionate people, are part of that technology transfer, it is hard to make that happen. So in a very small way, what I had learned in my life is I was involved with 2 startups that were based on technologies developed in the lab in my whatever university, one at Northwestern, one at University of Illinois, Chicago. I went on leave. The PhD students that are part of this, they joined the company, brought in people with experiences. So you cannot just do it with graduate students and the professor. You need to bring in talent. So the model here is take a half a dozen of the researchers from HP Labs that originally worked on that connectors, Exascale, this, that technology, partner them with a dozen engineers from business units, along with some sales marketing people, and incubate that technology, show a prototype, show the market acceptance before you ship it over to the business unit. That is the model that we are working on. Now there will be some technologies that will go to business units, others that we will license to the outside world. So there is a set of things that we are working on in terms of tech transfer. HP Labs in these last 40 years has created an amazing set of technologies that has benefited society and benefited HP economically as well. Starting from the first HP computer, the thermal inkjet printing, HP's first laser printer, the HP Indigo digital press, which was an acquisition, but HP Labs did tremendous work to make that really successful post-acquisition. the Halo life size collaboration that I just mentioned about connections and other things. In the last couple of years, this year particularly, there has been a lot of very interesting technologies that have already transferred to various business units. And I don't want to go through all of those, but I just mentioned the dynamic smart cooling about this technology. I mentioned Mag Cloud. This is this technology on creating magazines on the cloud. And it is something that literally, if you are interested, you can go to magcloud.com and publish your own magazine. There are 4,000 customers that people actually people are using for this. Book Prep is a web service that allows people to publish long tail content. These really, really rare books you can publish on the web. Our charge roller, this is a technology for the large Indigo presses. Virus throttling for networking switches in ProCurve. So the lab has been creating some really interesting technologies. In the next couple of minutes, I want to talk about a topic that is very, very relevant to you in a university setting. That of open innovation. I mean, we strongly believe that the problems that we have identified, I mean, these are not just HP's problems. These are sort of the problems facing the information technology area. These problems are so complex that we cannot do it alone. So we need to partner with people outside HP labs through these relationships with academia, with startup companies, with government labs and others. We would like to amplify what we do. So there are several aspects of this. One is this HP Labs Innovation Research Program. One is a program that we have done with our commercial partners, Intel, Yahoo, and so on. So let me talk first about the commercial program, an example of a commercial collaboration. This is the CITRIS cloud computing testbed that was announced a couple of months ago. The observation is that when you have to do research on this massive scale cloud computing testbed, you cannot do it yourself. You need to partner with, so we have partnered with Intel and Yahoo, 2 commercial partners, and 3 university partners from UIUC, IDA in Singapore, and Karlsruhe Institute of Technology. Each of these centers are providing a research testbed about between 1,000 to 4,000 cores for people in academia and other places to just do research. You say, not a commercial testbed. You could, suppose you created a new web computing platform, some research thing, here is the interface much better than MapReduce and Hadoop. Go and try it out there. So in a university setting, you maybe have a Mickey Mouse operation with maybe 32 processors. It does not test for scale. So this testbed will allow people to test multi-data centers, 6 data centers, multi-geography across 3 continents at significant scale. Now, starting with about 24,000, it will scale up because we plan to bring in more data centers here. Massive scale, truly open testbed, and will test for security. So this is something we are very excited about. The Innovation Research Program is a program that we launched at HP Labs this year, and I will agree that it was not the perfect launch. We will improve it in the future, and I know some of you have been participants of this. But the vision was that in the past, HP and HP Labs used to fund research through relationships. It's a random acts. Here is a professor interested in this. There's a relationship, and you just fund this person. Instead, what we did is we told the world, these are the 5 broad themes that we have identified. These are our 23 separate labs. These are the projects we are doing within labs. So we went to great detail explaining to the world that these are the kinds of approaches that we are taking. Please partner with us and see if you can complement what we are doing. The response was tremendous. We got 450 proposals from 200 universities in 38 countries worldwide. We had finite resources in the beginning year. We plan to ramp it up in the future. So in the first year, we gave out 41 research projects with universities across the world. And you can see some of the universities. And I know this is a very sensitive topic. There are some of the UC campuses shown here, not Santa Cruz, but we will correct it in the future. Look, we know that you are located right here in the Bay Area, but essentially we did not want to do through, it was a very interesting process that I can go and talk about, but it was based on the quality of proposals and not trying to go after the geography, et cetera, et cetera. So at this time, the 41 projects they were in, so we picked a couple of projects in IIT, IIT Madras, IIT Bombay in India, Tsinghua University, Peking University in China, Technion in Israel. So these were very good professors in very good universities, and I know that there are some fantastic projects from UC Santa Cruz in storage and others and so on that I hope you can participate in the future. Yes. Can I take questions at the end? So I want to end the presentation by thanking you all for coming today and sharing what has happened in the sort of the modern research lab, how we have taken a stab at moving away from the large number of research projects into a smaller number of high impact collaborative projects, how we are doing technology transfer, and how we are practicing open innovation. Thank you very much for your attention. Questions? Question. Now is the time for questions. Yes.
So, as one of the people that submitted one of those video proposals, you got zero feedback from HP Labs on the proposal. How should we proceed to improve that? Relationship of more than a decade ended.
I need to know exactly what feedback you got. We were supposed to provide feedback on every project, but maybe this was a unique situation. I know that the Open Innovation Office had tried to provide reviewer comments back, but if you did not, that is something that I will follow up on.
None of the PIs here got anything.
Okay, so this is good feedback for me to, remember, HP has got 450 proposals. I could not be involved with, I had an Open Innovation Office. They were getting up to speed on this thing. We did not expect this many proposals to come in, so all the HP Labs researchers were involved in the reviews and so on. From the 450, we picked about a short list of about 90, and then we brought it down. So those 90 or so got a lot of attention and discussions and labs, and then we whittled it down to 41. And I don't know where you were in the process, but this is good feedback, and I will take it back to the OAIO team.
How large were the awards? How large were the awards?
75,000 to 100,000
Nothing
per year. There were, I think, a few at 50, but these are 3-year awards.
And what is the total budget that HP has for those awards currently?
So if you do the math, average of
Sun is $1 million that they're giving out for innovation awards. What is HP getting out?
it is about 2 to 3 times that. It is about $3 million this year,
And next year?
and we will look at that next year.
It's an ongoing program.
It's an ongoing program. So the thing is, see, remember, these research programs, you start with the university, you don't just dish it after a year, right? You start and they continue for 3 years, and then next year you bring in some more additional people, and then you start a pipeline, and that's where we are headed.
So 41 awards and about $2 to $3 million divided by 41. Okay, that's all.
Any other? Yeah.
Okay, so you talked about preparing HP Labs and, that times have changed from the glorious days of the early years of the computer industry where we had ATT Bell Labs, we had Xerox PARC, we had tremendous innovations, many of which took decades to bring to affect the consumer. But we could see them. We could see them coming. We had these wonderful videos that gave us some insight into the world of the future. SRI, Doug Englehart's video, kind of stands out in my mind as the hallmark. That's what the world is going to be like in 10, 20 years, and sure enough it was. Is HP, do you have any budget for 10, 20 years down the road crafting the?
We have 1/3 of the budget. That's why I said we have $150 million in HP Labs. 1/3 of that research is for visionary research.
And can you give an example of one of those visions today?
So an example is a project called Sensi that I didn't have, we couldn't talk about. A sort of a vision of the world having a billion to a trillion sensors that would sense everything, right? Built on really interesting sensors in the future, sensor technology, and collecting all this data from these trillion sensors and deriving some intelligence from it and providing very interesting experiences back to the consumer or the customer. Another technology is a thing that came out called the memristor that people are working on at HP Labs. Memristor. This is in electrical engineering. You have heard about resistor, capacitor, inductor, and so there's this fourth element called the memristor that.
Stan has given talks here at CITRIS.
So we have exploratory work from Bernardo Humerman's lab on social computing, where they're working on technologies for how people in a social computing session, social networking, can create viral marketing, how people can collectively, sort of collective intelligence of the crowd, and that would be an example. And we have others. In the Exascale computing lab, some exploratory work in fundamental new programming technologies that will allow people to write killer applications in the future, having this multi-cores and many multi-cores and so on. So those are examples of long-term research.
Time for one more question. Yeah.
You briefly touched on the technology transfer challenge, and that moving paper and documentation is not sufficient, that you need to move people from the research core into the company or the business unit that is developing the actual product. There's a long literature and long experience at this point, since at least the 70s, with doing that. The problem is we see that people tend to work well at sort of a basic level, an applied level, or a manufacturing level, and they don't transfer back and forth terribly well. People who've worked in basics don't want to be in operations and manufacturing. How have you addressed that within the lab so you have a fresh core of creative, innovative people that have enough experience to actually do meaningful work?
So the key thing is that when you transition these people, I'm not talking of transitioning them permanently to this other organization. When researchers are within labs, the metrics that they're evaluated with are, have you advanced the state of the art through publications in conferences, journals, patents, etc., and doing some tech transfer, right? But the people in the businesses, their incentives are driven by profit and loss, next quarter's revenues, and so on, right? And so when you create a technology and hand it over to a person in a business unit, that catching function is not as, there's an impedance mismatch, and so it did not happen. So the concept is just like in an academic setting, people go on sabbaticals. Now, we are not talking of 1 year, maybe it takes a couple of years, leave, and those graduate students go in. But if just those people were trying to create a technology and form a business, it will be a disaster. So then what you do is you loan people from the business units to work on this technology, and that is the key thing. So when you're creating this incubation organization, these people for that 2-3 year period will have different metrics. Both groups will have different metrics. The labs people will move away from the publication patent game into let's build this product, right? And the business unit people will forget about the revenues and so on and say, how can I take this product into a thing with 5 referenceable customers? And look, this, as I said, this is where we are headed, and we have looked at lots of models. This is a model that we will adopt. Success, I need to come back in 5 years and say, this is what happened.
Oh, okay, I'd like to thank you.
Thank you.
So the next set of presentations are on the 5th floor. Just go down here up the elevators to the 5th floor on both sides. Thanks very much.
Thank you.